This is the first revision session for the P2 unit, and in this revision session we'll be looking at how we get energy from the sun in terms of solar power. By the end of this session you should be able to explain how energy can be generated from the sun and some of the advantages and disadvantages of photocells. Now clearly the key word for this is photocell. Now normally you'd probably call this a solar panel, but the proper name that we need to be using in the exam is photocell, and quite simply it is something that absorbs light energy and transforms it into electrical energy. It's also important to remember that they produce direct current. This is the same as you get from a battery, and so this is the opposite of alternating current which you get from the mains. The amount of current that's produced depends on the area of the solar cell that has the light shining on it. Okay, so the big question is, how is the energy from the sun converted into electricity? In order to do that, we need to take a closer look at the photocell and what it's actually made of. Okay, looking more closely at the photocell, you can see that it's made of silicon atoms. Now, these silicon atoms get hit by the radiation from the sun, and when they absorb that energy, they give off electrons. These electrons flow down the circuit and then can be used. Now, there are certain advantages and disadvantages to using photocells. Let's see if you can think about what they are. So pause this slide and take a couple of minutes to try and work out what the benefits and disadvantages would be. Right, so here are the advantages and disadvantages. Firstly, they require very little maintenance. This is mainly because there are no moving parts to wear out. Secondly, they can be used in remote locations, in the desert, out at sea, or even out in space on satellites or the Hubble Space Telescope to generate the electricity they need. And finally, there's no waste, especially no carbon dioxide or any greenhouse gases, which are going to have a negative impact on the environment. There are, of course, some disadvantages. Firstly, you need to have a large area. To generate enough electricity for a town, you would need to cover quite a few fields with solar panels to generate the amount of electricity needed. Secondly, they don't work at night or in any other times where you don't get a great deal amount of solar radiation, so when it's cloudy they're not going to work as efficiently. And finally, they are expensive to buy. Obviously that's counteracted by the fact that there's very little maintenance costs, but your initial outlay is quite high. Now, you need also to be able to recognise the three methods by which you can increase the amount of electrical output from a photocell, and this is a really common question that is found in exam papers. So have a guess now at the three methods by which you can increase this electrical output, and then I'll give you the answer to that in a minute. You've had a chance to think how you can increase the amount of electrical output from a photocell, so here are those three methods. You can either increase the light intensity, i.e. make the light brighter, or you can increase the surface area of the photocell, or finally you can reduce the distance between the light source and the photocell. Well, if the sun is our main source of light for photocells, this presents a problem. I'm not quite sure how we could reduce that distance, but if you're using a different light source, then clearly you can reduce the distance between it. Now let's have a look how these are given in exam questions. Here's a question about photocells from a recent exam. You need to be able to describe how light produces an electrical current in a photocell for 3 marks. That means you need to make 3 distinct points to make sure that you get the marks. If you pause this slide and come up with your 3 points, and then I'll go through the answer. Right, the 3 marking points that we're looking for in this exam question are firstly that the radiation needs to be absorbed by the silicon atoms in the solar panel. There's the first mark. The second mark is that an electron is released when the radiation is absorbed. And thirdly, the electron travels down the circuit. So that's your 3 marks. 1, silicon absorbs radiation. 2, an electron is released. And 3rd, the electron travels down the circuit. Now I'm going to show you a 6-mark question, and this might take a little bit more thought. So have a read of that question and then try and work out what your 6 marking points are. The 3 ways to increase the amount of electricity are light intensity, surface area and the distance. Now this question is clearly about the size of the different surface. Therefore, you need to make sure that your answer keeps the intensity and the distance the same. So how do we get 6 marks? Firstly, we need to explain what the relationship is between the surface area and the amount of electricity produced. So you would need to say that the larger the surface area of the photocell, the greater the amount of electricity produced. What you then need to say is about keeping the other 2 things the same to ensure that it's the surface area that is causing the increase in electricity. So this means you need to say that the light intensity needs to be maintained the same at all times when you're testing all the different size photocells. You also need to mention that the distance between the photocell and the light source is going to be the same all the time. If you're going to test this in a lab, it would be a good idea to have an electrical light bulb that is going to create the electricity to make sure that you keep that constant distance and the constant intensity of light, because sunlight can change. If a cloud goes overhead while you're doing the experiment, that's going to affect your result. You will also want to discuss how your experimental technique is going to ensure validity of results, how you would measure use a ruler to measure the distance between the light source and the photocell, and the readings that you're going to take, either current in the form of amps or potential difference in the form of volts. You would then be able to produce a graph of surface area of the photocell against current, or surface area of the photocell against the voltage, and you can, whilst keeping all other variables the same. Well, that comes to the end of this presentation, so you should now be able to explain how energy can be generated from the sun. You should also be able to list some of the advantages and disadvantages of photocells, as well as being able to answer exam questions about it. As I said at the start, this was the first presentation from the P2 unit. There are going to be other presentations shortly that are going to include passive solar heating and how the sun is responsible for the wind, and advantages and disadvantages of wind power and wind turbines. So look out for these in the future.